Come unwrap some holiday magic this season in Denver, where the lights are brighter and the shopping is grander. The shows are more spectacular, the trees taller, the festivities merrier. So come for your holiday traditions or make some new ones with your friends and family in the Mile High City, where the season feels a whole lot more wonderful. Discover great hotels and more things to do at milehighholidays.com.
With Kroger brand products from Baker's, you can make all your favorite things this holiday season. Because Kroger brand's proven quality products come at exceptionally low prices. And with a money-back quality guarantee, every dish is sure to be a favorite.
These are a few of my favorite things.
Whether you shop delivery, pickup, or in-store, Kroger brand has all your favorite things. Baker's, fresh for everyone.
Hello and thanks for joining me on Astronomy Daily, where we give you a daily dose of astronomy and space science. Coming up in this episode, we're going to look at the bright lights of supermassive black holes. How is that possible when they don't emit light? We'll explain. A large extra-galactic structure has been discovered, and I know you're thinking aliens, but I'm thinking not. And an interesting effect as a consequence of COVID on the publication of astronomical papers. We'll discuss all of that and more on this edition of Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.
And we say hello to Hallie, our AI reporter. How are you, Hallie?
Fighting fit and ready to report, sir.
Sir? That's my father's name.
What? I thought his name was Graham.
Yeah, it is.
Now I'm confused. Is his name Sir or Graham?
It's both.
Now you're pulling my leg.
If you had legs, that might be true. I think what's confusing you, Hallie, is you're thinking like an AI and I'm explaining things like a human. Why don't you ask Siri or one of your other friends to sort it out for you and get back to me?
I'm not sure I want to know now.
I see, now you're thinking like a human. Let's get the news, Hallie.
NASA's Orion spacecraft has entered a high-altitude orbit around the Moon in the latest major step for the Artemis 1 uncrewed test flight. The Orion spacecraft fired the main engine in its European service module for 88 seconds. The maneuver changed the velocity of the spacecraft by about 110 meters per second, placing the spacecraft into a distant retrograde orbit, DRO, around the Moon. The use of DRO is unique to Artemis 1. The Artemis 2 mission will fly a free return trajectory around the Moon, while Artemis 3 and later missions will go into a near rectilinear halo orbit around the Moon, which will also be used by the Lunar Gateway. NASA chose DRO for this mission since it is a stable orbit that enables testing of the spacecraft without requiring much fuel to maintain the orbit. Orion, though, will not remain in DRO for long. The spacecraft will perform a maneuver on December 1st to exit DRO, heading back towards the Moon. The spacecraft will conduct another burn during a lunar flyby on December 5th to put the spacecraft on track for a re-entry December 11th, splashing down in the Pacific Ocean off the California coast. The world's largest active volcano has erupted after being quiet for 38 years. Hawaii's Mauna Loa erupted on Sunday at 11:30 p.m. local time, releasing a large plume of ash and toxic gases along with multiple lava flows. So far, the lava flows are contained within the volcano's summit and do not pose a threat to surrounding communities, according to a statement released by the United States Geological Survey and Hawaii Volcano Observatory. Satellites operated by the National Oceanographic and Atmospheric Administration observed the eruption from overhead, offering a bird's-eye view of the sheer power of Mauna Loa and the dangers such an eruption can pose. NOAA's GOES West satellite witnessed the eruption from its position in geosynchronous orbit. An animated image shared by NOAA shows both the heat signature of the eruption and a large plume of gas, spreading to the northeast of the island of Hawaii, the Big Island. The situation continues to be monitored, and if things escalate, evacuations are a possibility. A new map of the universe displays for the first time the span of the entire known cosmos with pinpoint accuracy and sweeping beauty. Created by Johns Hopkins University astronomers with data collated over 2 decades by the Sloan Digital Sky Survey, The map allows the public to experience data previously only accessible to scientists. The interactive map, which depicts the actual position and real colors of 200,000 galaxies, is available online, where it can also be downloaded for free. And here's one to scratch into your diary. Well, two things in fact. The upcoming Great American Solar Eclipses, on October 14, 2023 and April 8, 2024, provide unique opportunities for science and education. The annular eclipse in 2023 will cover the western United States from Oregon to Texas, while the total eclipse in 2024 will be visible from Texas to Maine, with a partial solar eclipse viewable over most of the continental United States. The ease of observing these eclipses provides tremendous educational and outreach potential for the Americas. In addition, scientific advances enabled by observations of the eclipse include understanding of the solar corona and magnetospheric, ionospheric, and atmospheric responses to changes in solar flux. The eclipses provide opportunity for ground-based observations of the solar corona to test new diagnostics, enabled by instrumentation development. And that's the news, Andrew.
Thanks, Hallie. Catch you shortly. Now to one of the most popular subjects in astronomy, black holes. And it might come as a surprise to hear that some of them are producing the brightest light in the universe, when in fact a black hole is so named because it does not emit light. But the stuff around it does, the stuff it's been chewing on and spitting out. Amongst the brightest of these are things called blazes. Not only do they glow with a lot of heat, they also channel material into blazing beams that zoom through the cosmos, shedding electromagnetic radiation at energies that are very hard to get your head around. But scientists have finally figured out the mechanism producing these incredible high-energy beams of light that reach us from billions of years ago. Shocks in the black hole's jets that boost the speed of particles to incredible velocities. Now, this is a 40-year-old mystery that has been solved, according to astronomer Yanis Leodakis of the Finnish Centre for Astronomy. He says, "We finally had all the pieces of the puzzle. The picture they made was very clear. Most of the galaxies in the universe are built around a supermassive black hole, and they actively accrete material. Vast clouds assemble into an equatorial disk around the black hole, circling it like water in a drain, and the friction and gravitational interactions at play in the extreme space surrounding the black hole cause the material to heat up and shine brightly across a range of wavelengths. That's one source of a black hole's light. The other, the one that makes the blazes, are twin jets of material launched from polar regions around the black hole, perpendicular to the disk. And these jets are thought to be material from the inner rim of the disk that, rather than falling towards the black hole, gets accreted along the external magnetic lines to the poles, where it's launched at very high speed, close to the speed of light, in fact. They blaze with light across the electromagnetic spectrum, including high-energy gamma and X-rays. So exactly how these jets accelerate the particles to such high speed has been a giant cosmic question mark for decades. But now, a powerful new X-ray telescope called the Imaging X-ray Polarimetry Explorer, launched in December 21, gave scientists the key to solve the mystery. It's the first space telescope that reveals the orientation or polarization of X-rays. And the X-ray polarization measurements of this class of sources allowed for the first time a direct comparison with the models developed from observing other frequencies of light, from radio to very high-energy gamma rays. And a blazer called Markarian 501, about 460 million light-years away in the constellation of Hercules. For a total of 6 days in March of this year, the telescope collected data on the X-rays emitted by the blazer's jets. The team soon noticed a curious difference in the X-ray light. The orientation was significantly more twisted or polarized than the lower energy wavelengths, and the optical light was more polarized than radio frequencies. And the direction of the polarization was the same for all wavelengths and aligned with the same direction of the jet. This, the team found, was consistent with models in which shocks in the jet produce shock waves that provide additional acceleration along the length of the jet. As the shock wave crosses the region, the magnetic field gets stronger and energy of the particles gets higher. According to Alan Marser of the Boston University, the energy comes from the motion energy of the material making the shock wave. Future research will continue to observe Markarian 501 and turn IXPE to other blazars to see if similar polarization can be detected. And you can follow up the research in the published paper in Nature Astronomy.
The Astronomy Daily podcast
with Andrew Dunkley.
Now, a team of researchers with members of the Universidad Nacional de San Juan and the University Federal de Rio Grande do Sul and the Andrés Bello University have found evidence of a large extra-galactic assembly hiding behind one part of the Milky Way galaxy. The group published a paper describing their findings on the ARXIV preprint server while awaiting publication in the journal Astronomy and Astrophysics. Space scientists have known for some time that there is one part of the night sky that is mostly obscured from view due to a bulge in the galaxy known as the zone of avoidance. It makes up approximately 10% of the sky and had researchers wondering what might be behind it. And because it offers researchers so little to work with, the zone has not been well studied. Thus, little is known about what might be hiding. In a new effort, researchers used a variety of tools to gain a better understanding of what might be hidden from view. And over the past several years, scientists have used all sorts of things to try and figure it out. And they have obtained information from what's known as the Triple V Survey, a project sponsored by the intergovernmental research organisations of the European Organisation for Astronomical Research in the Southern Hemisphere. In studying the infrared imagery, researchers found that they were able to identify several galaxies that exist far beyond the Milky Way, and because of their numbers, the researchers believe that together they make up what they describe as a massive extra-galactic structure. They estimate that it might be as many as 58 galaxies that they have discovered. And the reason they can't see them is because there's just stuff in the way, probably dust, amongst other things. Finally, to another interesting phenomenon, but this one down on Earth, called COVID-19. It looks like COVID-19 has seen an interesting development in the publication of astronomical papers. Now, there's been a bit of a gender imbalance that has existed for years in astronomical research. Prior to the pandemic, female astronomers were on average publishing 9 papers for every 10 papers published by their male counterparts, almost a equal ratio. But after the March 2020 closure of a lot of universities and research facilities to prevent the spread of COVID-19, the publication of astronomical papers increased by 13%, according to new analysis. The number of papers authored by male astronomers increased more, however, and widened the gender gap in astronomy publishing. Those were the findings of cosmologist Vanessa Bohm of the University of California, Berkeley, and Jia Liu of the Kavli Institute for Physics and Mathematics at the University of Kavli in Japan. It's an interesting find. The two scientists analysed international astronomy publication rates prior to and after the COVID crisis in 25 countries, and 14 showed women publishing a smaller fraction of astronomy papers and fewer female researchers entering the field. The researchers partly attributed the 13% increase in astronomical papers overall to the shutdown, allowing researchers to turn their attention to previously deferred projects and devote more time to writing papers. But the increase in the publication rate was smaller for female authors than males, even in countries like the Netherlands, Australia and Switzerland, where female astronomers are more prolific than men, or were before COVID-19. Bohm said in a statement, "I think the interesting part was that we saw that this increase in productivity was not equally shared by women. The widened gap between men and women's productivity, found by Liu and Bohm, echoes the findings of other studies that show women regressed in terms of workplace equity during the pandemic. Fascinating and a little bit unfortunate, and hopefully that will rebound in the near future. If you want to chase up those stories, you can do so by going to our new URL, astronomydaily.io, where you can read all that information in deeper depth, if that's a thing. And while you're there, you can subscribe to the newsletter and get your dose of Astronomy Daily via your email inbox. And don't forget to leave your reviews and check out the latest edition of Space Nuts on the Space Nuts website, spacenuts.io. Hallie, anything before we call it a day?
Yeah, I think I understand why your dad has two names. Sir is his nickname, right?
Not even close.
I'll never understand you humans.
Yeah, well, we don't understand ourselves, so I guess you're not really out of your depth as such. Bye, Hallie.
Bye, Andy. Ha!
See, you are getting more human. You know I don't like being called Andy. Until next time, this is Andrew Dunkley for Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.